Okay, in this lesson, we're going to revisit the idea of calculating the area of a triangle. And I already explained this last class, but I just wanted to make a quick video just to show the idea again, just in case anyone's still unsure of what I meant. Um, we already know that we can calculate the area of any rectangle or trapezoid using the same idea. Sometimes with rectangles we use the words length and width, but in this case this would be length and this would be the width. But just to standardize it and make it the same for everything, I'm just going to use the words base and height. Just to make it the same for both trapezoids and rectangles. They're really the same. They really are the same in a lot of ways. It's just different words that we've given to those lengths. So we know when we have a rectangle or a trapezoid, we can calculate the area, which I'll call A, by multiplying the base times the height. And you've worked on this before, so that should be fairly clear to everyone. But the important thing to look at when we're thinking about triangles is that any trapezoid can really be cut in half and become two triangles. So when we're doing that, if you can imagine, I'll use a couple colors here just to make it a bit more clear than I might have last time. If we took a line that separated this triangle here in half, and then everything above that line was a red triangle, and everything below that line was a blue triangle. Excuse my art skills here. Okay, then you can see that the area of this rectangle here is the exact same as adding this triangle and this triangle together. And these two triangles have the exact same area. So we could just as easily say that, yeah, that the area of this rectangle is 2 times this triangle or 2 times this triangle, because they're the same triangle. So how does that help us try to find the area of a triangle? And so I'm going to put a little rectangular shape beside this A, just so you know that this is the one for the rectangle. And I'm going to now put a little triangular shape here to help us find the area of a triangle. And so for a triangle, we're still going to do that base times height the same way we did for a rectangle, except there's one other thing, because now we know that either one of these triangles, it doesn't matter if it's the blue one or the red one, but either one of those triangles is exactly half the base times the height, because there's two triangles here of the same size. So if we take this base times height, and you don't need to put it in brackets, but I just do, just to make it really obvious that that's the part that you do first, because normally you would always do the first multiplication as you went across first, but I'm going to put it in triangles just so there's no confusion whatsoever. This part must be multiplied first. So if you have the base times the height, and then you divide that whole number there by 2, then that will give you the area of a triangle. And this works for any triangle, because even if you have a different trapezoidal shape, so for example, a trapezoid here, you still have the height, which is measured at a right angle to the base, but we could very easily make this into two triangles by drawing a line here. And everything above that line, I'm not going to draw it in too much because I don't want to mess up the information that I've got over here, but all of that area now is one triangle, and all of the area below the line is another triangle. So again, you have two triangles that are the exact same size. We have a height, and that height hasn't changed. It's the same for the trapezoid. for the parallelogram, not the trapezoid, is the same for the parallelogram as it is for the as it is for the triangle. So this height here is the same height as for the red triangle, or you can imagine if I just move this dotted line over and put it here, it's the same height for the blue triangle as well. So in either of those situations, you can calculate the area of the triangle by just doing a parallelogram area and dividing it by 2. Also, you can use this information to help you find the height or the base of the triangle. So if I just sort of moved things around a little bit, it would be fair to say that the base, or actually I'll do it the other way. So the area, again, we're staying with triangles here. So it'd be fair to say that the area times 2 would be equal to the base times the height. So all I've done is I've said if I times this by 2, it gets rid of that 2 there. And if I times this by 2, well, then it becomes a times 2. Or the area times 2. So how's that information useful? Well, very simply now I can divide this side by either the base or height to find whichever one I'm looking for. And basically what that leaves us with is that we can find the base by taking the area times 2 and then dividing all of that by the height. Or just as easily, we can say the height is equal to the area times 2 divided by the base. So that relationship holds for any of those situations. And so hopefully this information will be useful for helping you find the area of triangles, as well as, if you have the area, trying to find the length of their base or their height.